right. I decided to re-podcast this particular one just because I wanted to clarify a couple issues on this particular standard here. So welcome to Chapter 11. Chapter 11 is all about conics. And so for conics, I'm going to show you in class about talking about how we can cut a cone with a plane. Remember, plane in geometry is a flat surface. And so we're going to cut it in such a way that different shapes are going to emerge. And I'll briefly talk about that also again in 11.2, so I may as well take you right there. So in 11.2, this is what's happening. So that purple figure that you see on your screen is showing how it's slicing the cone in different ways. So if the plane is coming in from the upper left and then slicing it down, then what we have is a parabola. And we've actually studied some things about parabolas already. And if you remember some of that stuff, that's great. And then there's going to be even more stuff about parabolas that we don't know yet. So we'll talk about focus and directrix. And we'll talk about vertex form and transformational form, because really the only thing we really focused on before was talking more about graphing a quadratic in standard form. We talked about solving quadratics and things like that. In example 2, I have 2 slices. If I slice it with the bottom slice, I'm going to get a circle. And so that can be considered a conic. If I slice it, like the upper example in number 2 here, and I'm slicing it from upper right to lower left, then I'm getting something called an oval, which we call an ellipse. And then finally, I could have a plane that's just so big that it slices both cones. And if that happens, then it makes not 1, but 2 parabolas, so we call that a hyperbola. So let's get back to what we need to do, which is talking more about graphing today and talking about vertex form and transformational form. So hopefully a couple things that you'll remember from our quadratic chapter, which was way back in first semester. Hopefully you remember that standard form of the equation is y equals ax squared plus bx plus c. And our axis of symmetry was x equals negative b over 2a. And so to do this, we first figured out what's A, what's B, what's C. We plugged it into the formula. And then from there, we decided instead then to figure out what it was, and then plug that number into the long equation, get the number out, and then that would be our vertex, and then we'd go to a table of values. That is one way to graph a parabola if it's in standard form. But now we're going to focus on a different form, which is called vertex form. And so here's vertex form on this particular page. The A value is, again, still going to tell me, just like how in the other format of standard, shows me whether this parabola is going to open up or if it's going to open down. So if it's a positive number for A value, it's going to open up. If it's a negative value, it's going to go down. The H value, get used to conics with seeing H and K. So we're going to be having H is going to represent my axis of symmetry, and my HK together is going to give me my vertex. Notice that there should be a minus in front of the H, and there should be a plus in front of the K. If we don't see those signs, remember that means a negative must have been put in. So please keep that in mind. All right, so our next focus is to be able to just look at an equation and pick it apart. Can you, now that it's in vertex form, give me the axis of symmetry and then the vertex? And then we're going to stop. So for the first example, what we're going to be doing, so we have the axis of symmetry is going to be found here. It should be a minus, and it is. So my axis of symmetry is 2. Let's take a look at the next equation. X is going to equal, again, it's minus, so we're good on that, 4. So that's my axis of symmetry. If I go to my third example, there's a plus sign there. So that means there must have been a negative that was put in there to change it to a positive. And then finally, for our last example, what if there isn't any number at all after the x? Then it's just 0. Now, let's find their vertexes. So to find the vertex, the first number in every ordered pair is your axis of symmetry. So by finding a correct axis of symmetry, half your work is completed. Then, to find the rest of the vertex, we look at the K value, and it should be a plus, and it is in number 1. So my vertex is just going to be 2, 3. In number 2, there is no number after it. So that's going to be good old 0. In number 3, I've got a negative, so I shouldn't have a negative, so that tells me it's -1. And finally, there isn't one again, so then it's going to be 0. By the way, number 4 is a parent function, and so we talked about parent functions back in first semester. So now let's utilize this skill and put it into graphing. So here's the equation that I want you to graph. And so the first thing you want to do again is write your axis of symmetry. So my axis of symmetry, that should be a minus in that 2, and it's not. So therefore my axis of symmetry is at -2. So I'm going to draw a vertical line going down. So that's my folding line. Remember, talk about symmetry with parabolas. Then we're going to find the vertex. So with the vertex, we're going to have -2 be part of it. And remember, the k value is supposed to be a plus, and it is. So my vertex is at 2, 3, -2, 3. And there isn't a number in front of the parentheses, so other than a 1. So this tells me that this lovely parabola is going to open up. Now we're going to go to a table of values. So for our table of values, that's my vertex. Remember, we always go 1 to the left of the axis of symmetry and 1 to the right of the axis of symmetry. So we're going to have -3 and -1. And because of symmetry, I only have to plug in one of these numbers because I'm going to get the same outcome. Remember to do order of operations. So first we have to do -1 plus 2, which would be 1, square that, which is 1, and then 1 plus 3, which will be 4. And so I'm going to be at 1, -1, 4, and -3, 4. And then we really need 2 more points. We really kind of need, for a good parabola, you need 5 points. So we're going to go 1 more to the right, which will be 0. 1 more to the left, which will be -4. Let's plug in our good buddy 0 because he's nice. So 0 plus 2 is 2. Square that, we'll get 4, and then 4 plus 3, which is 7. And then we're going to put those in. And then graph your parabola. And we're done. Let's look at the next example one for graphing. And then we'll get on to the next part. Notice there's a 2 in front. Remember, we talked about vertical shrink, vertical stretch, things like that. So again, start to remember some of those things. And so we're going to first do the axis of symmetry just like before. So we're going to end up getting, it's supposed to be a minus in there and it's not. So my axis of symmetry is at -3. Again, my good old wonderful vertical symmetry line. Then get the vertex. So it's going to be -3 what? Well, this is supposed to be a plus, and it's not. So therefore, my vertex is -3, -1. But since it's 2 for my axis of symmetry, or not my axis of symmetry, for my A value, this is going to open up as well. And again, get our table of values. So again, -3, -1 is my vertex. Go 1 to the left of -3 and 1 to the right of -3. Pick one of those to plug in. I'm going to work with -2. So be careful plugging these in. It's always order of operations. Parentheses, exponents, then multiplication. So we're going to have -2 plus 3, which is going to be 1. 1 squared is 1. 1 times 2 is 2. And 2 minus 1 is 1. And there's those values. So we have -4, 1, and -1, 1. Then I need one more step, so I'm going to go 1 more to the right, which is going to be 0, and 1 more to the left, which would be, oh, pardon me, I take that back. I put him in his wrong spot. So that is incorrect. We are actually not going to 0 at all. We're going to -1 and -5. And so we're going to put one of these in. Let's put in the -1. So when we do that, we're going to end up with 2. 2 squared is 4. 4 times 2 is 8. And 8 minus 1 is 7. And so I'm going to put those in. So I have -1, 7. -5, 7. Again, it's a little bit steeper because again, it's basically having that vertical stretch occur. Okay? So that's graphing. Now the second part of our standard that we're going to learn is talking about transformational form. So can we take our parabola, and it's going to be in a basic, what we call basic conic form, and turn it into transformational form. And this is something where we're going to need to do this because we're going to talk about soon a directrix and a focus. And this is where we really get into pre-calc. And so I want you to be exposed to these ideas before you go into pre-calc. So I have transformational form. This is the one we're going to focus on. So x minus h squared equals 4p parentheses y minus k. For now, I'm not going to get into the p-value with you. That's going to come in a preceding podcast. So we don't need to do that. So we're just going to focus on rearranging the equation and then from there getting the vertex of that equation. And again, we're trying to not put it in the directions here. It says standard form, but it's really not. It's really transformational form. Okay, so for example number 1, it's kind of like separating, you know, this goes over here to the left, this goes over here to the right. So we want to separate the x's and the y's. The x's are going to get shifted to the left, and the y's are going to get shifted to the right. So in order to do that, the x squared and the minus 10x, they're both x's. So they're going to stay on the left. On the other side, I'm going to leave a little space here. I'm going to move the y over. So if I move the y over, that's like adding y. So that's going to be a positive y. And I also am going to move the 25 over. So it's a plus 25, so I'm going to subtract 25 both sides. So it's a minus 25 now on the right-hand side. So I've separated my terms. Next, we get to do a personal favorite of mine from first semester. We get to do complete the square. And so when we complete the square, we're going to cut this middle term in half. So this negative 10 gets cut in half, and we're going to square it. So that's going to be 25. But remember, if I add something to one side, I need to add something to the other side. Notice something really cool happens with my 25s. On the right-hand side, they cancel. They just make y. And then on this side, now I want to go back, and I want to do my second favorite thing in the world, which is factor. So now I have to factor this because it's a perfect trinomial. So I'm going to have an x. The first sign always tells me what goes, so minus. And then square root your number, which was 5. This is enough now to tell me, hey, I'm ready now to do what my vertex would be. And we don't need to worry about much after that. So my h value is 5. And notice there isn't anything after the y. So therefore, k must be 0. And there's my vertex. Okay? We'll take it more with the other pieces when we get into the 11.1 plus. Okay, next in number 2. Again, first thing you want to do, rearrange your furniture. So the x's are on one side, the y's are on the other. So the negative y comes over here. I'm adding y both sides. And then I'm subtracting 4 both sides. So now I've got a y minus 4 over to the right-hand side. Next, what we would like to do is complete the square. So that's my second thing to do. So we're going to cut that 6 in half and make 9. And again, if I do that to one side, I do it to the other. And so therefore, I'm going to factor this. So x, oh, the next sign's a plus, so it's a plus. Square root that 9, that's 3. And then I'm going to have y, and I'm going to put these together, plus 5. So now I know, okay, this is a plus. So therefore, my vertex must be negative 3. And this is supposed to be minus also, instead of being a plus 5. So my vertex must be negative 3, negative 5. Again, it helps if you write that equation on the top of your paper or the top of the section. That always seems to get me going in the right direction. And then our last 2 examples are focusing on when is there a number in front. Oops, I switched the page. So this is when, wait a minute, my x squared has a number in front of it. This is like bad, like muy malo, bad. We don't want to have a number in front of the x squared other than 1, because otherwise we can't complete the square. And that's really bad. So what we're going to do is we're going to do some fun factoring out. So first, separate your pieces, just like before. I'm going to move the y over, so I'm adding y both sides. The 0 we don't care about. Then the next thing we'd want to do is factor out the 2, because I can't complete the square until I do that. So now I'm going to divide out the 2. So this is now going to become 6x. Okay, now we're okay. I'm going to focus on completing the square inside the parentheses. So cut the negative 6 in half, which is negative 3, square it, which would be 9. Now notice, I'm not going to add 9 to the other side, because really, it's not 9. It's really 2 times 9. So 2 times 9 is 18. So I technically have to add 18 to the other side to make it equal. Then I'm going to have the 2 here. We'll worry about that in just a minute. Factor this out. So we're going to, again, x minus, because of the first sign, square root the 9, which is 3. And then I'm going to have y plus 18. Technically, I can pick off the vertex right now, but in transformational form, you don't want the 2 there. You want that's going to represent part of that 4p that we're going to get to. So I want you to divide both sides by 2. So then we're going to have x minus 3, quantity squared, equals, we're going to just call this 1/2, and then parentheses, y plus 18. That is going to be considered transformational form. And so now I can pick apart my vertex. It's going to be 3. This should be a minus over here, and it's not. So therefore, it's negative 18. All right, let's go through that process one last time. So for the next example, we have to do the same thing. So rearrange your furniture. Subtract the 2y both sides. Subtract 36 both sides. Then from there, what we're going to want to do is factor out a 3. I can't complete the square until the x squared becomes a 1. 24, make sure you divide that by 3, so that's negative 8. I'm going to leave a space, because eventually I'm going to complete the square. And so that's what we have. Now let's complete the square. So we're going to cut that negative 8 in half, which is negative 4. Square negative 4, and I'll get 16. Don't add 16 to the other side. Instead, remember we got to account for that 3. So 3 times 16 is what we need to add, which would be 48. So now I have a 3, and then let's factor this. X minus square root your 16, which is a 4. And then I'm going to have a negative 2y, and add the 48 and the negative 36, and we'll get 12. Now we're almost there. We have a slight problem, though, this time with the y side, with the right side. So we can't have that be negative 2y. We need it to be just y. Otherwise, it's not fitting this format. So therefore, what I'm going to do is factor out a negative 2. And by the way, even if y is negative, factor out a negative 1. You have to have it just be y. So now I'm going to have y. 12 divided by negative 2 is negative 6. And I'm almost there. The last step is to divide by 3, because this is going to help me with my 4p value. And so I'm going to have negative 2/3 in front here, and then y minus 6. And then now I can be able to pick off my vertex. So I'm going to have 4 and 6. And so that's kind of, again, what we're covering in that beginning of the conics section. Next podcast coming up in the series is going to be 11.1 plus, talking about a focus and a directrix. As always, have a great day.